Today, I'm excited to share with you 5 unique science experiments. So, let's dive right in and explore the world of science together. Number 1. Oobleck is a fascinating non-Newtonian fluid that defies our expectations of how liquids behave. Its unique properties make it a perfect experiment to explore the science of fluids. So, let's dive deeper into the mesmerizing world of oobleck. To create oobleck, you need 2 simple ingredients: cornstarch and water. In a large mixing bowl, gradually add water to the cornstarch while stirring. Keep adding water until you achieve a gooey and thick consistency. You want the mixture to be fluid when you pour it, but solid when you apply pressure to it. It's like a magical substance that transitions between liquid and solid states. Now, get ready to experience the wonders of oobleck firsthand. Dip your hand into the bowl and notice how it feels slimy and wet, like a typical liquid. But as you squeeze it or punch it with force, you'll be amazed to see it resist your efforts. It will feel solid and offer resistance to your touch. You can even try rolling it into a ball in your hands, only for it to melt back into a liquid when you release the pressure. It's like playing with a substance that has a mind of its own. The secret behind oobleck's behavior lies in its unique viscosity and shear thinning properties. Most liquids, like water, have a constant viscosity, meaning they flow easily regardless of the applied force. However, oobleck's viscosity increases when pressure is applied, causing it to become thicker and more solid-like. This behavior is due to the interactions between the cornstarch particles and water molecules, forming a suspension that resists flow under pressure. Number 2. To conduct the Cartesian diver experiment, you need a few simple materials: a plastic bottle, water, and a small object that can sink, such as a paperclip, an eyedropper, or a small piece of clay. Let's embark on this scientific journey together. Begin by filling the plastic bottle with water, leaving some air at the top. Take your chosen sinking object, such as a paperclip, and carefully attach it to the inside of the bottle cap. Make sure the object is securely attached but still able to move freely. Screw the cap back onto the bottle tightly, ensuring no water leaks. Now comes the fascinating part. Squeeze the plastic bottle gently and observe what happens to the sinking object. You notice that as you apply pressure to the bottle, the object begins to sink further into the water. This occurs because the pressure exerted on the bottle compresses the air trapped inside, reducing its volume. The decrease in volume increases the pressure inside the bottle, causing the object to sink due to the increased pressure on it. On the other hand, when you release the pressure by loosening your grip on the bottle, the object will rise back up to the surface. This happens because the pressure inside the bottle decreases, allowing the trapped air to expand and regain its original volume. Number 3. This experiment combines the principles of chromatography with the beauty of flowers, resulting in stunning patterns and a deeper understanding of color separation. To conduct the chromatography flowers experiment, you need a few simple materials: white coffee filters or white paper, water-soluble markers in various colors, scissors, and a container of water. Let's dive into this creative and scientific exploration together. Start by cutting out flower shapes from the coffee filters or white paper. Make sure the flowers are large enough to showcase the vibrant colors of the markers. Feel free to experiment with different flower shapes and sizes to add a touch of creativity to your experiment. Next, it's time to create your colorful masterpiece. Take a marker and draw circles near the center of the flower shape. Be generous with your strokes to ensure a good amount of ink is applied. Choose different colors and create multiple circles on each flower to add variation to your experiment. Number 4. Get ready to power up your curiosity and dive into the world of electricity with the fascinating lemon battery experiment. Did you know that you can generate a small electrical current using nothing but a lemon and a few simple materials? Let's explore the science behind this experiment and uncover the hidden power of citrus. To conduct the lemon battery experiment, you need a fresh lemon, a copper coin, such as a penny, a zinc-coated nail, 2 insulated wires with exposed ends, and a small electronic component like an LED bulb or a digital clock. With these items in hand, let's harness the power of chemistry and create our own lemon-powered battery. Start by carefully inserting the copper coin and the zinc-coated nail into the lemon, making sure they are a few centimeters apart, but not touching each other. The coin and the nail will act as electrodes, with the lemon's acidic juice serving as an electrolyte. Now, connect one end of a wire to the copper coin, and the other end to the positive terminal of your electronic component. Take the second wire and connect one end to the zinc-coated nail, and the other end to the negative terminal of your electronic component. Make sure the connections are secure and that the wires are not touching each other. Number 5. Prepare to explore the invisible power of ultraviolet (UV) light with the captivating UV beads experiment. These special beads have a hidden secret. They change color when exposed to UV light. Let's dive into the science behind this phenomenon and unlock the wonders of UV radiation. To conduct the UV beads experiment, you need UV-sensitive beads, also known as UV beads, and various light sources such as sunlight, fluorescent bulbs, or UV flashlights. With these materials in hand, let's embark on a colorful journey and uncover the mysteries of UV radiation. Start by examining the UV beads in their current state. They may appear white, clear, or pale in color. These beads contain a special pigment that is responsive to UV light, but it's not until you expose them to UV radiation that their true colors will emerge. Now, it's time to expose the UV beads to different light sources and observe their mesmerizing transformation. Step outside on a sunny day and hold the beads in direct sunlight. Watch as they instantly change color, shifting into vibrant hues of red, orange, yellow, green, blue, or purple. This transformation occurs because the UV-sensitive pigment in the beads undergoes a chemical reaction when exposed to UV light, resulting in a visible change in color. Experiment further by exposing the UV beads to other light sources. Place them under fluorescent bulbs or use a UV flashlight to see their color-changing magic indoors. You can even test how different materials, such as sunglasses or sunscreen, affect the beads' response to UV light. Observe how the colors intensify or fade based on the level of UV radiation they receive. Thanks for watching.